It's okay. It may never make your it may never make it onto your Spotify, but that's okay.
Well, maybe not ever again.
All right, so example J is where we left off. Now we did lots of all these were two-step equations. We haven't done any so far that have had parentheses, but we have simplified expressions that have had parentheses. And the way that you simplify an expression that has parentheses is you distribute. So today, what we're going to do is we're going to look at some, not just some two-step equations, but some that are maybe three-step equations, where I might have to clear fractions, or I might have to distribute, or I might have to combine like terms. Both of these you've already done. I'm going to show you how to clear fractions today, because on your e-learning worksheet, we have these really big fractions that we're looking at. So we'll look at those. Okay. But if I have parentheses, what I do is I take the number in front of the parentheses and I distribute it to the terms that are inside. And that's what distribute means. So let's go ahead and get started with example J. 3 has to get distributed to the J and to the -4. Thomas, what's 3 times J? What is it? 3 times J? How do I write 3 times J, Bryce? No? Okay, well, I can tell some people haven't started their homework. Branson, how do I write 3J? Sorry, I just said it. Yeah, you just squeeze them together, right? 3 times J is just 3J. Thomas, what's 3 times -4? There we go. Okay, so by distributing the 3 to the J and to the -4, I've gotten rid of the parentheses, and I've made that -4 a -12. Now I just have a two-step equation. So that was my first step. Now for my second step. Rayleigh, what number am I trying to get rid of here? Remember yesterday we said, not the 3, that's the brother-sister bond, right? The 12, what kind of 12 is it? What's in front of the 12? There we go. Georgia, can you get the door for me again? I'm sorry. Yeah, so let's add 12 to both sides. Because it's a -12, the only thing that'll make it go away is a +12. Okay. Yeah, so we have the brother-sister relationship, which is the coefficient with the variable. That's a tight bond between them. It's a blood bond, right? Then you've got the -12, distant relative. It's in the family, but not in the same house. So that one's, we're getting rid of that one first. So the -12 and the +12 will cancel each other out, just leaving us the 3J term.
It could be in your house. My cousins.
Okay, that's true. That's true. Typically they don't, but for some families they do. Okay, so maybe we should say the I don't know, the second aunt's great-great-grandson that's a step-grandson. Does anyone have one of those living with them? Shush, Parker. All right, what's 9 + 12?
Well, not anymore. They don't look at
21, thank you. We'll get back to math. And then now I can break that bond between the coefficient 3, not the constant term. Constant term's already gone. -12's gone. The coefficient term is the term that's always with that variable. And so that 3 is being multiplied to J. What's the opposite of multiplying? Dividing. What's 21 divided by 3? 7. So J = 7. Guys, this is your homework. This, like, I don't know. I like this stuff, especially when it's all integer operations. And I have worked with integer operations since day 1 of school. How many colors did I use for that problem? 3. This was they snuck a 3-step equation on you. Have to distribute first, then we had to add 12, then we had to divide by 3. None of those steps were very difficult to do, by the way. If I asked you to do 3 times -4, you could do it in your head. 9 + 12, probably do in your head. 21 divided by 3, those are all mental math facts. We just did 3 of them, and it's the same problem. We just did 3 of them together. If I told you your homework tonight was going to be multiplying 3 and 7 together, or sorry, 21 divided by 3, or doing 9 + 12, you'd say, oh, that's really easy. Well, that's what we're doing. That's what we do to solve these equations. Example K. Ashlyn, what number do I need to get rid of first here?
The 5.
Not the 5. You mean the 2? Okay, what kind of 2 is it?
Negative.
And what's going to get rid of a negative 2?
The positive 2.
That's right. Positive 2. Yeah, we're going to leave the 5. That is a stronger relationship than what the negative 2 is to the K. Okay, the 5 and the K are blood brothers, relatives, brother, sister, whatever you want to call it, but there's a type on there. So we're going to get rid of the negative 2 by adding 2. Ashlyn, what's 17 plus 2? 19. We got 19 equals 5K. Okay, that's my first step. Step number 2. Branson, what do I need to do to both sides to get rid of the 5 now? All right. Branson, how many times is 5 going to 19? It doesn't go in evenly, does it? Okay, so I have 3 options at this point. Gotcha, thank you. Okay, sorry about that. I have 3 options at this point. I have to do 19 divided by 5. So I can go off to the side and I can do 19 divided by 5 like this. Top dog gets the house, right? We're used to doing that. Branson, how many times did you say 5 goes into 19? 3 times. What is 5 times 3? Okay. We subtract and we get 4. So option number 1, put a decimal point, second decimal point, drop a 0 down. How many times 5 go into 40? Exactly 8 times. Make your answer 3.8. That's option 1. That's not very difficult, but that's one of your options. Option 2. Get rid of all that. Because your answer never said it had to be a decimal, you could, once you get 3 and then get that remainder of 4, you could literally take that remainder and put it over your divisor and just say that's going to be 3 4/5. It didn't say that you had to write it as a decimal or a mixed number. You could do whatever you want to do. 4/5 is 0.8. Or there's option 3. And option 3 is to do none of that. Option 3 takes you all the way to right here. 19 divided by 5. Looks an awful lot like a fraction, doesn't it? You could just write 19/5 as your fraction. That's it. You don't have to do any long division. If you're dividing by a number and that number does not go into the number you're dividing by, just write it as a fraction. So as soon as you put divide by 5, you just literally turn it into a fraction. More often than not, if I go back to the last problem, isn't 21/3 a fraction? But 21/3 gave us 7. We needed to simplify that, right? Well, here's our fraction for this one, but 19/5 doesn't simplify. There we go. So I just put 19/5. You could write any of these 3 options: decimal, mixed number, or improper fraction. Now, if you're going to do that, just so you know, for example, if I was doing one like this, and I divide both sides by 8, there's my fraction, right? So x equals 20/8. Can I leave it as 20/8? I can't. This one I could because 19/5 didn't reduce, but here 28 does reduce. It reduces by 2. Then it reduces by 2 again. No, I'm just giving another example. Okay. So if you have one like that where the number you're dividing by does not go in evenly, you can just leave it as an improper fraction as long as your improper fraction is reduced. Don't leave it as 20/8 when it reduces. Here, this one didn't reduce. 19/5 is perfectly fine. If you want to go off to the side and you want to do the division and make it 3 4/5 or make it 3.8, that's also fine. All right, example L. Bryce, what number do I want to get rid of first? That's right. What's going to get rid of a positive 5? Good. Bryce, on the right side of the equal sign is that 9 and -5. They're going to join forces or go to war? Who wins? By how many? There we go. On the left side of the equal sign, I'm left with that -L/3. Now, I'm going to have to get rid of 3. I'm also going to have to get rid of the negative. So when I write it on my paper, I'm going to write it like this. I'm going to take that 3. Remember we talked about that yesterday? Take that negative that's out down in the middle and drop it down to that number I'm dividing by. That way I can package them together and ship them both out. Ella, what's the opposite of dividing by -3? By -3. That's really important that she said -3. If there's one mistake I see more often than not with two-step equations is that we just times by 3. And they'll say, well, you put the opposite number here. Why don't I put the opposite number there? Because here I'm getting rid of a constant. By putting the opposite number, Bryce is subtracting 5. Here, though, as soon as Ella said multiply, that's the only opposite we're allowed to do. If you just multiply by 3, only the 3 cancels out. You still can't have the negative there. So you got to multiply by -3. So it's really important we do that. Ella, what is 4 times -3? -12. L is equal to -12. L is one of those variables I stay away from because when I write like I'm writing the word hello, my L's are straight up, look like 1s, right? So I stay away from L. If I do write L as a variable, I curve it like that. I also stay away from the variable O because O's look like what? Zeros. Yeah, so I don't want to confuse myself. X is a great number or a great letter to use, but sometimes you want some variety. I understand that. Now let's get into some more complicated equations, or maybe they're not as complicated as they look. One of the steps that we are going to, so we've distributed. Okay, we just did one. We had to clear parentheses not too long ago. Now I'm going to show you how to clear fractions. That's one of our steps. It's actually the very first thing we should try to do. So if you look at this next problem, 3/5 g minus 1/3 equals -10/3. So the way that I'm going to clear fractions, what do I mean by that? Well, I'm going to get rid of the denominators. If you get rid of a denominator, you no longer have a fraction anymore. So how do I do that? Well, I'm going to multiply both sides of the equation by the LCD. What does LCD stand for?
Least common denominator.
Least common denominator. If I had to find a denominator, what is the first multiple of 3 that's also a multiple of 5? 15. So when I say multiply both sides by 15, I mean I'm going to multiply every single term on both sides by 15. And you might be thinking, why am I doing that? That doesn't seem like that makes sense for this problem. Because 15, when Branson said 15, he's choosing the very first number that 3 goes into, that 5 also goes into. And the fact that they go into it means the 5 and 3 will cancel. If I'm multiplying top and bottom, remember I can cancel. If I'm multiplying fractions, I can cancel. The 5 on bottom cancels with the 15 on top. How many times does 5 go into 15? 3. So I'm asking you to do 3 times 3. 9. So this term is now going to be a 9g, no more fraction. Over here, the 3 on bottom is going to cancel. This is really 15 over 1. So it's going to cancel with the 15 on top. How many times does 3 go into 15? 5. So I'm asking you to do -1 times 5. -5. No more fraction. If you cancel your denominator, you don't have a fraction anymore. And then on the right side of the equal sign, we're going to cancel the 3 with the 15. We just said it went in 5 times. So I'm asking you to do -10 times 5. -10, -50. That to me seems like a pretty useful step. Because now I don't have any fractions. Now, do you have to do that step? No, you don't have to do that step. You could add 1/3 to the -10/3. And then you could divide by 3/5 as your second step. Remember, dividing by 3/5 is the same as multiplying by its reciprocal 5/3. You could do all that. We've done that even in one-step equations. But I like this one better. Maddie N says, what number do I want to get rid of first? How do I do it? Good. Cancels out. On the right side, Maddie, I've got -50 and +5. They're going to go to war and make what? Good. Aiden, what's my last step here? Divide by 9. Because the 9's being multiplied, we're going to invert that. We're going to divide. Aiden, what's -45 divided by 9? -5. That's right. Example N. Now we're going to learn how to do those ones like we just saw on our e-learning worksheet that we're going to do tomorrow. N minus 7 all over 4 equals 9. This is also a problem that I can clear fractions on. Although I could do this problem, example M, I could do that one without clearing fractions. I don't have the choice for N. So remember, clearing fractions is the very first thing I should try to do. And so I don't have the choice. I have to get rid of the 4 here. I have to clear this fraction. So what is my lowest common denominator between 4? What's my lowest common denominator? What is it, Georgia? It's just 4. Yeah, there is no other denominator, right? So there's no guessing work. Like here, I had to find one that worked with the 5 and the 3. Here, there's only one denominator. So when I ask you to multiply both sides by the LCD, there only is one denominator. We're going to multiply both sides by 4. That's not going to do anything to the 7, by the way, because as soon as I put times by 4 on that left side, it is immediately going to cancel out with the divide by 4. So really nothing happens on the left side other than I have no more denominator. And if I don't have a denominator, I don't have a fraction. You're allowed to do that? Yes, you are allowed to do that as long as what you do to one side, you do to the other side. So I can't just do that and say it equals 9, but I can do that and say that it equals 9 times 4. What's 9 times 4? 36. I can do that and say it equals 36 now. What number do I want to get rid of? What kind of 7 was it? What kind of 7 was that? A -1. So I have to put a +7. And what is 36 plus 7? 43. So let's recap on that, because again, you're going to do that a lot on your worksheet. Whatever your denominator is, clear it by timesing both sides by that number. Timesing both sides by 4 doesn't actually mean I times the 7 and the 4 together, because timesing the left side by 4 just cancels out with the denominator. I'm just left with whatever my numerator is, n minus 7. Timesing the right side by 4 is what I'm actually going to do. 9 times 4 is 36. These are really easy ones to do, actually. Times by whatever the denominator is to clear that fraction, you're left with n minus 7 equals 36. That takes us back to Tuesday of last week. Add 7 to both sides and you're done. Remember to simplify if possible. The very first step in our steps to solve equations wasn't dividing. That was the last step, multiplying, dividing. Wasn't adding or subtracting. That was the second step. The very first step was to simplify if you can. We just cleared fractions. We've distributed. Now we're going to have a problem where we have to combine like terms. And that's the next one we're going to look at here. -8d minus 5d plus 7d equals 72. That's a lot of d terms on the left side. All of those d terms are like terms and can be combined. Maddie Cheeseman, what is this term? Okay, so I have to include the negative as part of that term, right? Maddie, what's the second term? -5d. And what's the last term? +7d. Combining like terms means I'm going to add all those together. But when I add terms together that have different signs, I subtract. And when I add terms together that have same signs, I add. So be careful here. Let's just go 2 at a time. Maddie, the first 2 terms you gave me were both negative. So if I add them together and they have same signs, should I join forces or go to war? Join forces. What's -8 and -5 make? If I lost anybody on that one, we combine the -5 and the -8 D to make negative. Okay. So now what we're going to do is we're going to do that same thing again. We're going to combine the -13D and the +7D. This time, Maddie Cheeseman, are we going to join forces or go to war? This time it's war because they're different signs. First two numbers had same signs. Add them. Second two numbers have different signs. Subtract. Maddie, the negatives win by how many? Not 5. -60. Yep. 6D, not 60. -6D equals 72. So I combined all three of those. If you can do all three of them in your head at one time, that's fine. I just didn't want to confuse anybody, so I just did them 2 at a time. First 2, then the last 2. Georgia, what's my last step? How about -72 by 6, -6, or 72 by -6? I think I got the gist of what you're saying, but yeah. What's important is that when we divide, we just don't divide by 6. Don't take the opposite of -6. You've already done opposite as soon as you say divide. If you only divide by 6, and this again, this is why I keep harping on this, because everybody, this is the most common mistake I see. You'll just divide by 6, and then you'll say the answer is 12. Well, actually, only dividing by 6 only gets rid of the 6, and you have to get rid of the negative sign. So it should be divided by -6, which makes it a -12. So good job in dividing by -6 on that one. Okay, example Q. I see parentheses, Parker. What's that mean? Nope. You can't just times the 6 to the Q. There's something else in those parentheses. So Parker, whenever you have parentheses, this is when we want to use the distributive property, where we take the number in front and we multiply it to all the terms in the parentheses, not just the first one. Okay. So when I distribute the, where was I? There it is. When I distribute the 6, you said 6Q, and that's right. But Parker, I also have to do 6 to the -2. What's 6 times -2? -12. Yeah. So don't forget about that. You got to multiply it to both numbers, or if there's more, usually there's only 2, both numbers in the parentheses, and then that gets rid of the parentheses, and then that's gone. Parker, I'm giving you a second shot here. What number do I need to get rid of now? What kind of 12 is it? And what's going to help me get rid of a -12? Yes. Yes. So +12, +12, +12, +12, same thing. Parker, -18 and +12 are going to join forces or go to war. Okay, who wins and by how much? Negative by 6. There we go. Which works out very nicely. Because Hannah Lindley, what's my last step? Okay, and what is -6 divided by 6? -1. Yeah, it goes in nicely. I'm going to squeeze that down, shrink this a little bit. Ran out of room. There we go. All right, Thomas, back to you. I see parentheses. What does that mean? -8, you mean? Okay. What's -8 times y? Good. And then I have to do it to both of the terms. So what's -8 times +9? -72. So when I'm done, it says -8y minus 72. Excellent. That was my first step. Now for my second step. Rayleigh, what number do I need to get rid of? Yep, and it's negative, so I'm going to put, it already is negative, so I'm going to put, there we go, cancel it out, good. The +72 or the +72 cancels out with the minus. And then Rayleigh on the right side, I've got -40 and +72. We're going to go to war or join forces? Positives are going to win by how many? How much bigger is 72 from 40? Okay. Or we could go off to the side to do it, right? Because I'm guessing you don't have that many fingers. 72, we're going to go to war, which means subtract. 2 minus 0, 7 minus 4. There we go. Positive 32. Ashlyn, what's my final step?
You want to add 8.
Nope. Don't add 8. I've already done my adding. Yes. Yeah. This negative 8y doesn't mean it's being subtracted. It means it's being multiplied. So the opposite of multiplying, as she just mentioned, is dividing. Ashlyn, what am I going to divide by? No. Negative 8. I thought you just said 8. Yeah, negative 8. I'm going to divide by negative 8 because if I only divide by 8, the negative's still there. Divide by negative 8, and it's just y. And then Ashlyn, what is 32 divided by negative 8? Yep, there we go. And then example S. And then we have what, 2-story problems to do? Example S, there's a lot going on the left side of that equal sign, Branson. What should I do first? Not yet. Yes, combine your like terms together. Remember, combining your like terms is one of those initial simplifying steps. I keep coming back to this, but again, that's because we're doing not just 2-step, we're doing some of these are 3-step equations now. So combining your like terms is one of those initial simplifying steps. And Branson, when you combine that positive 4 and that positive 3, that's going to give you, and then minus 2s equals negative 9. Bryce, what number do I want to get rid of now? Negative 9's already chilling by itself, Bryce. Nope, that's a blood relationship, strong bond. We're going to leave that for the end. What's the constant term that's on that variable side? We've already combined them. What did they make? 7. There we go. Yeah, you're just one step behind. So 7, we want to get rid of the 7. There isn't a sign in front of the 7. There's a sign behind it, but that doesn't matter. There's no sign in front of the 7, so we know it's positive. The opposite of positive 7? Negative 7. So I'm going to put minus 7 on both sides. The number one reason students would miss a problem like this isn't because they have to combine like terms to get 7. That's kind of simple to do. It's because when they copy it down, they just write this. What are they missing? Then it was a negative 2s, wasn't it? Yep, so you got to put that. And then on the right side, Bryce, negative 9 and negative 7 will join forces to make what? Negative 16. Yep, they join forces. They're on the same team. They stay negative 16. Okay. Ella, what's our next step? Divide negative 2 on both sides. Remember, she didn't say add 2, right? Because it's being multiplied. So we're going to divide by negative 2 on both sides because we want to get rid of the multiplying by negative 2. So we divide. And Ella, what's negative 16 divided by negative 2? 8. That's as tough as it's going to get. The perimeter of a parallelogram is 104 feet. Find M. Okay. Interesting one. What does perimeter mean? Bryce? That's right. Perimeter is the distance around a shape. And to find the distance around the shape, we are going to add all the sides together. How many sides are there on a parallelogram, Bryce? I only know 2 of them. Or do I? Maddie? That's right. That's right. So because we know for sure this is a parallelogram, the definition of a parallelogram is a quadrilateral, four-sided shape that has opposite sides parallel and equal. All parallelograms have equal sides, opposite sides. So I should say they're equal. So we know that the other opposite sides are the same. So when I do perimeter, or as Bryce said, add up all the sides, that would mean M plus 3M plus M plus 3M. And what does this problem say our perimeter is? And what does is mean? Equals. So the perimeter of the parallelogram, aka M plus 3M plus M plus 3M, is means equals 104. There is my equation, and there's lots of like terms I can combine here. Remember, if there's no number in front of your variable, what are we going to assume is actually there? That's a 1, which means that's a 1 and that's a 1. So can you tell me what 1 plus 3 plus 1 plus 3 is? 8. Altogether, this makes 8M. When I combine that term with this term, with this term, with that term, that gives me 8M when I combine those terms, equals 104. Aiden, what do I do to solve this 8M equals 104 equation? Good. I don't know how, well, I don't know how many times 8 goes into 104 without doing it off to the side here. So this is my long division. 104 divided by 8. How many times 8 go into 10? You'll get you'll get a difference of 2. And then you're going to drop down to 4, and 8 goes into 24 3 times, and it goes in exactly, so we're done. So M equals 13. That wasn't very hard to do at all, actually. This one, on the other hand, well, it's also not hard, but we are going to have to comprehend what it's saying. The height at the top of a roller coaster hill is 10 times the height of its starting point. So let's look at this picture. The height at the top of the roller coaster hill is 10 times its starting height. So they're using the letter H for the starting height, whatever that is, like the platform that you're on when you start. And then at the top of the hill, you are 10 times farther up in the air. The height decreases by 100 feet when you make that drop. It decreases by 100 feet from the top to the bottom. And the height at the bottom of the hill is negative 10 feet because you're going underground, looks like, in a tunnel. Find the height of the starting point. So when it says define my variable, they've already kind of done that for me. What letter are we supposed to use? H, which is what I would have done anyways for height. So let H represent the height. The height of what? No, the start. Yeah, the height of the start, or the starting point, or the platform. Yeah, we know that the top of the hill is 10H. We're trying to find the platform. So we're at the top of the hill. How tall, how high up in the air are we at the top of the hill? Nope, nope. What's our number for the top of the hill? 10H, 10H. We don't know. We don't know how tall it is. We can find out here in a second though. So there's me at the top of the hill. I'm going to go down the hill. And when I go down the hill, my height decreases by 100. And when I'm at the bottom of the hill, what's my current height? Negative 10. So that is going to equal negative 10. There's my equation. Top of the hill is 10H. I go down 100 feet. Now I'm at negative 10. Maddie Yen says, what number should I get rid of first? Okay, what helps me get rid of a negative 100? What's negative 10 plus 100? Negative, are you sure?
No,
Yeah, the positive. So I agree with the 90. The positives win the war though, right? Okay. And then Maddie Cheeseman, what do I do to finish this? Okay, divide by 10. What's 90 divided by 10? 9. And so what are we measuring in here? Feet. So it's a story problem, needs a label. My height at the starting point, AKA the platform, is 9 feet. Now, this is not what the question was asking, but can you tell me how high up in the air I was at the top? 90 feet. 10 times h is now 9, so 90 feet would be my height at the top. That doesn't seem very high. I'd believe it more if it was like 20 times the height, but 10 times the height
So
doesn't seem as
have
good.
you ever been on a roller coaster?
I have.
I've only ever been on one.
Which one did you go on?
It was in Holiday World.
Oh, I love Holiday World. They've got some wooden roller coasters there, but they're very like you feel like you've been in a fight afterwards. Like you get beat up on those wooden roller coasters.